Hello everyone, and in this video, we're going to be talking about a very important configuration that arises in Olympiad geometry. So without further ado, here it is. Suppose you have a cyclic quadrilateral ABCD, and you drop the altitudes from D to AB, BC, and AC. And suppose they are X, Y, and Z as you see here. Well, what can we say about these points? Well, it turns out that they are all collinear. They all lie on the same line. And this is a really strange fact, but it is true. So, how can we go ahead and get started on proving this? One way to prove collinear points is show that if there's an arbitrary point, then angle AYZ is equal to directed angle AYX. In this case, it feels like D is the most reasonable way to apply this. So let's try showing that directed angle dyx is equal to directed angle dyz, as that will be enough to show that all of these 3 points are collinear. Let's try looking at this one first. How can we try relating it to other points in the figure? We have this right angle here, so let's go ahead and mark that, and we also have some more right angles, so let's go ahead and mark those. And now we immediately see what we have. We have that bx dy is cyclic. So bx dy is cyclic because of the opposite 90-degree angles. So consequently, if we draw this line, we end up having that directed angle dyx is equal to directed angle dbx. Similarly, we have that dyzc is also cyclic. So that means that directed angle dyz is equal to directed angle dcz. But then this is also equal to directed angle dca, because CZA are collinear. Similarly, this one becomes angle dBA. So it suffices to prove that these two are equal. But this should be obvious because they are on the quadrilateral, on the circumcircle of ABC. So ABDC is cyclic, as we already know, which means that these angles are equal. Consequently, all of these 3 points are collinear. It turns out that the converse is also true. If D is a random point, it could be here, here, or anywhere, and the feet of the altitudes are all collinear, then this quadrilateral must be cyclic. And this is a very useful technique in proving that a quadrilateral is cyclic when you can't do it directly. Because all of these conditions are true regardless of whether ABDC is cyclic, and the only condition that we need to check really is this one equaling that one. And if you want to put a name to this theorem, it's called Simson's theorem, which states that x, y, and z are collinear. And this line x, y, z, it's denoted by Simson's line, named after Simson. Let me go ahead and spell it out. So Simson. So that's it for this video. Thank you so much for watching this video, and I'll see you in the next one.